Hello, Cloud Warriors. Welcome to Cloud Vidyalaya Tech Discussions. Today, we are going to start a new series on cloud networking. As part of that, we are going to discuss an important concept called IP address. As subtitle says, wherever you go, whatever you deal in the internet, IP address follows like your shadow. Before we proceed, we have a small announcement for you folks. Cloud Vidyalaya is coming up with a unique program on cloud and DevOps engineering. This program is for 3 months and students can choose their own choice of cloud between AWS, Azure, and GCP. This is designed for all section of audience, like students who are coming from non-IT background, for the folks who wanted to switch their career to DevOps engineering. In this program, we are going to cover 12 plus large-scale project, industry projects. Along with this, we are also going to help you in your profile building, like GitHub, LinkedIn profile building, as well as your resume preparation. The best part of this program is we are going to create a corporate scenario where students will work like a team to deliver these projects, and your mentor will be available 24/7 as a team lead to help you deliver these projects. Folks, if you are struggling to enter into DevOps industry, or if you are learning cloud and DevOps engineering, if you are planning to learn cloud and DevOps, then this is the best platform for you. Please reach out to the below number or email if you wanted to have a demo with us. You can only join if you like our approach and demo. Without further delay, let's go into the session. Folks, while you are learning cloud and DevOps engineering, especially cloud, whether it's AWS cloud or Azure cloud, you may come across something called as network. Like if you are learning AWS, you may come across VPC and subnets. If you are learning Azure, you may come across something called as VNet. So while using or while creating this network, you may see some numbers, this kind of numbers, right? Or if you are creating this network, you may see some words like subnet mask, internet gateway, NAT gateway. Right? They are very important things, and you should know the details from basic. The reason is you can still create a network without knowing few of them by using some tools which are available online. But if some issue arrives in your system, and if your manager asks you to basically troubleshoot and fix the issue, it will be very difficult for you if you don't know the basics. So this video is especially designed to basically cover the basics of IP address in our networking. Right? So what is IP address? So if you observe, every house nowadays is having lots of gadgets. Right? You may wonder how these gadgets are getting communication. Right? How they're able to communicate with one another. Right? You are using your laptop, you're using your TV, you may be using smartwatch, you have mobile, right? You have all the electronic appliances like air conditioner. There is a need for them to basically communicate with one another. So have you ever wondered how they are getting communicated? Right? So let's say you have a system, you have a machine which it wants to talk to another machine in the network. So how should this your machine can reach out to that another machine? An example, right? You are basically staying in Hyderabad, and you wanted to reach out to your friend who is staying in Delhi. How do you reach out to him? Basically, you need to know the address of that person. Similarly, if this server has to reach out to this server, the server B, then it needs to know its address, which is called as an IP address. So every device you use, you will have an IP address. So who is going to assign the IP address to these devices? The answer is your router. So every day in your house, you can see the routers. And so the router is going to assign the IP address to all the devices within its network. Clear? So what is the format of IP address? IP address is a 4-number notation. An example is 192.168.10.3 separated by dots. Each division is called as an octet. We will see why we call it as an octet. Clear? Now, before we go deep dive, first we need to understand that your machine, any machine which you are using, it may be your laptop or server, only deals with zeros and ones. Let's say you wanted to send some message to your cloud saying, hello, Mr. Computer. It won't understand because it don't know the language. Like if you are going to abroad and if you wanted to communicate with the foreigners in your own language, they won't be able to understand, right? In same way, computer don't understand the plain English or plain numbers. It always deals with binary. Clear? Now let's discuss binary. So let's convert the previous IP address we saw into binary. What is binary? Binary is nothing but zeros and ones. Let's convert one of the number into binary. Let's take this IP address and let's take the first number and convert this into binary. How can we convert the number into binary? There are two ways. You can follow whichever it is easy for you. So I'm basically following the division method. So 192 divided by 2, 96. And the remainder is 0. Again, 48, remainder is 0. 24, 0. 12, 0. 6, 0. 3, 0. 2 ones and 1. So you can reach till 1 or 0 in the end. Right? So what is the binary representation of 192? Starts from the base here till reach till here. So it's 1, 1, 0, 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7. So you are representing the number of this octet using 8 digits. 8 digits binary, 8 binary digits. Right? We call them as bits. So we are representing this 192 using 8 bits. That is why we call this part of the IP address as an octet. Now let us convert another important number called 255 into binary notation. 255. This time I'll use another approach. I'll write down few numbers. 2 power 0 is 1, 2 power 1 is 2, 2 square is 4, 2 cube is 8, 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64, 2 power 7 is 128. Now, can we deduct 128 from 255? Yes, so write 1 here. 255 minus 128 is 127. Can we deduct 64 from 127? Yes, so keep 1 here. Again, you will have 63. Can we remove 32 from 63? Yes, again keep 1. 31 will be left. Can we remove 16 from 31? Yes. 15. Can we remove 8 from 15? Yes. 7. Can we remove 4? Yes. Can we remove 2? Yes. So 255 means all ones. Please remember this. We are going to use this in upcoming sessions. So far we discussed about IP address and how to convert IP address into binary number. Now let's move to another topic. Let's take a small analogy. If you have to send a courier to your friend who is staying in another city, generally what we'll do, you basically hire a courier guy, and that courier guy will do the job for us. Right? So for the courier guy to reach to your friend's area, first he has to reach out to your friend's network. Right? Let's say your friend is staying in Bangalore. So first he has to reach Bangalore. And in that Bangalore, he can search his house. So using some pin code, he can reach to your, let's say the pin code is 5,55,000. Using this pin code, he will reach to your friend's network. And after reaching the network, he will use his house number plus some address combination to reach out to the particular house. Let's say this is his house. So here, the pin code can be termed as network ID. And the actual house number plus address combination can be termed as host ID. Using this network ID and host ID, the courier person is able to successfully reach out to your friend's house to deliver the courier. Now, this internet is nothing different. If someone has to reach out to you, your server, first he has to reach out to your network. And after reaching your network only, he will search for your server within your network. To basically understand this, let's type something called ipconfig. Let's open command prompt in your Windows and type ipconfig. you will get some outcome like this. There are three important things here: IPv4, subnet mask, default get. IPv4 again say your IP address of the device which you are using. And then there is something called subnet mask. This IPv4 is the private IP. I'll discuss what is private IP in upcoming session. And this is your subnet mask. The subnet mask is used to basically identify the network ID. We already discussed. To reach out to you, I need to figure out your network ID. So the subnet mask, using the subnet mask, I can decode the network ID from this IP address. Let us see how we can decode the IP address. I'm taking a small blank page. Now, we got our IP address as 192.168.0.38. Let's search. Now convert this IP address into binary. We already discussed how to do that. 2 power 0, 1, 2, 4, 8, 16, 32. Just write this table and this will help you to do that. Can I deduct? Let me try this IP. Can I deduct 128 from 192? Yes, so I'll keep 1. I'm left with 64. Can I deduct 64 from 64? Yes. Again, I'll keep 1. And I am left with 0. So I'll keep all zeros because there is no need for me to compute again. And 168 again. Can I deduct 128 from 168? Yes, I'll keep. I'm left with 40. Can I deduct 64 from 40? No, 0. 32 from 40? Yes, 1. And 0. And simply I'm left with 880. And remaining all will be zeros. And 0, I'll simply convert all zeros because 0 to binary notation will always be zeros. 38, again I'll do 128 I cannot deduct, 64 I cannot deduct, but 32 I can deduct. I'm left with 6, so 0, 0, 1, 1, 0. You can do the calculation. Now this is one. I already discussed the subnet mask which we got is 255.255.0. So this is used to basically identify the network ID of this IP address. Let's see how it is. If you basically convert 255 into binary, you will get all ones. We already discussed this part. Same thing. 1, 2, 3, 4. So I'll align each number with 255. 255. Now last one is 0. So I'll keep all zeros. Now you need to do an binary AND operation. What AND operation will tell you? The output of the binary AND operation will return 1 only if both are 1s. If I'm doing AND operation between these two IP addresses. So when I do AND operation, our output will be only 1 if both are 1s. So here both are 1s. So output will be 1. Here both are not 1s. There is 0 in the top. So it will be 0. Here there is 0. So 0, 0, 0, 0, 0. So basically, if you observe, when I'm doing AND operation with 255, which is all ones, I'm getting the same number only, which is in the top. Here also you'll get 1, 0, 1, 0. Second. Yeah. 1, 0, 1, 0, 1, 0, 0, 0. I'm getting all zeros here. So if you do AND operation with 255, you'll get the same number, which is. And here I'm doing AND operation with 0. In that, which means I'll get all zeros. If you do AND operation with 0, you'll get zeros. Now, if you observe the IP, when I again convert this binary to the decimal, I'll get something called as 192.168.0. Instead of 38, I'll get something called 0 because I got all zeros. So this is the network ID of the given IP address, which we got as part of our IP config command. Now let's move back to the same analogy. Right, so the subnet, using subnet mask, I was able to find out the network ID, which is this one, 192.168.0.0, which is the first IP address in the network. That means using, if you observe the subnet mask, the 3 octets, first octet, second octet, and third octet are basically dedicated for network ID. And in that network, there are different hosts possible. How many hosts are possible? 2 power 8 hosts are possible because only 1 octet is left for host. Each octet, there are 2 power 8 IP addresses possible, which is 256 IP addresses are possible. In that, ours is 98 IP address. So if someone has to reach out to you, first they have to reach out to your network, and after that network, they need to reach out to your house using your host ID, which is 98. Now, now a person in this, let's say this is a gated community with 4 houses. The person in one house can talk to another neighborhood person because they are in the same community, same network easily. But if you have to talk to someone who is outside of the city, let's say he has to talk to someone who has to communicate with someone who is part of another city. Now again, he will hire the courier guy, and that courier guy will act as an interface between him and the outer world. The outer world in this case is internet, right? Then this courier guy is called as default gateway. For every network you take, you will have something called as default gateway. The default gateway's job is to basically help people in the network to communicate with the outer world. Now you are able to watch this video because you are having a default gateway in your house. The default gateway is called as router. The job of router is basically help all the devices in your home network to communicate to the internet. Without router, you won't be able to watch the YouTube also, because YouTube is in the internet and you are watching from your home network. Clear? Now, so we discussed same analogy. I'll reiterate again. We discussed that the devices in the network can communicate with each other without any issue. But if they have to communicate with external world, they will use something called a default gateway, which is generally router in our house networks. So far, we discussed about IP addresses and decoding of IP addresses and how internet communication happens. Now let's move to another topic. So while designing the internet in the earlier phases, the IP address allocation happened, and that was happened in some notation called class notation, which is called class notation. So they divide the IP address ranges into 5 classes, and each class have with own network and hosts. Let's take class A. Any IP address starts between 1 and 126 will come under class A, and it is having subnet mask of 255.0. That means the first octet will be used for network ID, and the remaining 3 octets will be used for host IDs. That means how many hosts are possible? 2 power 8 plus 8 plus 8, which is 2 power 24 hosts are possible, which is coming close to 16 billion. How many networks are possible? 1 to 126. That means 126 networks are possible, and each network will be having 16 million hosts. That means this class A is representing larger networks. Like companies like IBM used to have these kind of networks in the earlier stages of IP addressing. Now comes to class B, where it is having the IP address range starts between 128 and 191. And how many octets are there for network ID? 2 octets, which means how many hosts are possible in each network? 2 power 16, which is 65K. And how many networks are possible? 128 to 199, one is 63 into 2 power 8, which is coming close to somewhere around 16,000 networks are possible, and each network can have 65,000 hosts. Again, it is also giving us larger networks, which is not feasible in smaller networks, right? Now comes class C, where 3 octets are used for network ID and 1 octet is used for host, which means 2 power 8 IP address, which is 256 IP addresses are possible in this network. And how many networks it is possible? If you calculate by yourself, you will get something called 20 million networks. This looks somewhat closer to the reality. Like 20 million, like all the household networks, all the small scale networks cannot have more than 256 devices. Like if you are using your home network, you may see devices, you may not see devices more than 10 or 20. Right? So these kind of networks suits that kind of home networks, right? Now class D and class C, E are basically dedicated for some special purposes, which is not basically used by any internet community. Class D is used for something called as multicasting. Class E is used for military and investigation agencies. Right? So these are not basically allocated to the internet. Now, if you observe this class notation, we observe that many of the IP addresses are not allocated to the internet. Like class D and class C are not available to the internet. And also we observe that Class A networks are basically stealing majority of the IP addresses. Like each network is having 16 million IP addresses. Let's assume a company has bought this network and they're basically using 1 lakh IP addresses only. That means remaining 1.59 million IP addresses are getting wasted. They are not being used by others. So this is ineffective allocation of IP addresses. Now to overcome this, they came up with some solution. But before we move to the solution, if you observe in this table, you see some number is missing. Can anyone figure it out? If you are able to observe that, please put it in the comment section. We see that 127 is missing here, right? 1 to 126 is there. Again, we went to 128 instead of 127. What is this 127? 127 in server always refers to self. That means if a server has to talk to itself only, then 127 IP addresses, 127 pattern will be used. Any IP address starts with 127 will be used by the server to talk to itself. As this pic suggests, 128 is like a introvert. Means a server is talking to itself. It helps the server to talk to itself. Right? Generally, when developers write the code, they basically try to deploy the code in their local machine itself and try to load that code to test it. Right? So in that case, the server is talking to itself to load the application. The famous 127 series IP address used is this one, 127.0.0.1, which is called as localhost, which is used to test our applications locally before we basically deploy to the servers. Clear? So now we observe that the IP addresses are inefficiently allocated in class notation. So there comes some concept called as private IP address. What this tells is, after those public IP address in classes, we took few IP addresses from each class A, B, and C, and we reserved them for private IP addresses. The reason we call them as private IP addresses is, any IP address within this network, let's say take a network A, and we say that these IP ranges are allocated for private IPs, which means let's say this is a private network. And in that, let's say one of the IP address is 10.11.12.13. Now, the servers in the private network can talk to each other because they are in the same network. But they cannot but people from outside, like server from outside, cannot reach this private network. Right? And if they have to talk they can again talk to internet, but internet cannot talk to them. They have a flexibility to download packages from internet using something called as NAT gateway. So the job of NAT gateway is basically enable the servers in the private network to communicate with internet to download something. But servers in the internet cannot talk to the servers in the private network. This communication is not possible, but this is possible using NAT gateway. So generally the NAT gateway is again the router itself. So if you take, let's say an house has different devices like mobile and TV is there, and then laptop is there in some house, and these devices will sit behind router. So each network will have router. So the router will allocate IP addresses, private IP addresses. So these devices can talk to each other freely because they are in the same network. But if they have to talk to internet, they will reach out to router first. And as I mentioned, internet service provider, who are the internet service provider you're using, they will allocate one public IP, 10. Some public IP, 1.2, let's say 1.2.3.4 to this router. And when this private server is basically trying to download a package from the internet, it won't directly download it from the internet. It will basically reach out to the router, and the router's job is basically to get the job done for the private server. It will first reach out to the internet, get the packages, and hand over it to the servers which requested. Now let us take two networks called network A and network B. And network A is having a server with IP address 10.11.12.13. So this starts with 10. So this is a private IP address. And a server in B can also have same IP address. But earlier we discussed that IP addresses are unique, but that is not the concept for private IP address. Private IP address can repeat in another network also because they are not unique. They are reserved for private networks. But public IP addresses cannot be repeated. They should. That's why your router will get a unique IP address. But the devices in your home, like when you type IP config in your command prompt, from your home, you will get some X IP address, and that X IP address can be repeated in another network also because they are private to that network. This is a very important concept. And if you observe, when you open your browser and type what is my IP, your house network will give some X IP address. And if you go to airport and again type the same thing like what is my IP in the browser, you will give it Y IP address because your router will be having public IP address. That public IP address will be unique. If you are in network A, your home network, it will give you X IP address. If you are in network B, let's say airport network, it will give you Y because airport network will have its own unique public IP. Now let us discuss an important concept called subnetting, which is the main agenda of this video. So while creating the networks, it is very useful. This concept will be used by you to understand how subnetting works in VPCs or VNets in AWS and Azure respectively. Right. Let's take an IP address again. 192.168.10.38. Let's take this IP address. And it is having 24 network bits. That means the subnet mask is 3 octets. So generally, you can represent IP address like this also, which means 24 bits, 3 octets are allocated for network ID and the remaining is allocated for host. Then how many hosts are possible? 2 power 8 hosts are possible, which is 256 hosts. Now let's assume you wanted to divide this 256 into again 4 parts for better network installation, called part 1, part 2, part 3, part 4. How can we do this? Next, we can do using the concept called subnet. Right? So let's write down our chart again. 1, 2, 4, 8, 16, 32, 64, 128. Now below that, write down the numbers which are double to the upper ones. Like 1 comes to 2, 2 to 4, 8, 16, 32, 64, 128, 256. Now write down the subnet mask into binary version. 1, 2, 3, 4, 1, 2, 3, 4, 255. Again 8 ones. Again 8 ones. And 0 is always 8 zeros. Now, to basically convert any network into different parts, you need to hijack some portion of its host bits. So you need to convert some portion of its host bits from zeros to ones. How many bits you need to convert depends upon the number of networks you need. In our case, I want 4 networks. So take the in the below row, see where 4 is there, and see its corresponding number in the above table, above row. So that means 2 bits we need to hijack to convert this given network into 4 parts. So we need to hijack 2 bits from left to right. So from here, 2 bits you need to convert to basically ones. If you want 16 networks, you can take how many bits? 8 bits you need to hijack from the right. Generally, in 8 networks, you cannot do in the /24 notation. You can either do 2 or 4. So if you want 4, you can convert into 4. And if you wanted to basically convert that into 8 networks, you can hijack 4 bits, which means another 2. Right now, we need only 2. Right? That you need only 4 networks. That's why we hijacked 2. Then how many, what the new subnet mask would be? 255, 255, 255. Again, if I convert that into binary notation, it will comes to 192. This is your new subnet. Then let's see what is the IP ranges for each of the new networks. We created 4 networks, right? So which starts with 192.168.10.0, the first network. And what is the increment? The increment is how we need to find out the increment, right? So the increment is number of zeros in the host bit, 2 power number of zeros in the host bit. Number of zeros here is 6. So 2 power 6 is the increment in the each network. So it's the IP address range is 192.168.10.0 to 192.168.10. From 0, if we add 64, it would be 63, because we are also counting 0. So this is IP address range of network 1. IP address range of network 2 will be 192.168.10.63 is done. So 64 to again increment 64, which comes to 128, because 127, because we're including 64 also. Either it should be 128, but we are also, because we are including 64, it will reduce. Network 3 would be again 128 to 191. Network 4, 192 to 255. So likewise, we can divide our existing network into 4 parts using the concept of subnetting. Now, this is one way. Another way is, let's say you wanted to have some n number of servers in each part you divide. Instead of you deciding how many networks you wanted to divide, you can divide your network based on the number of hosts you want. Again, take the same IP address 168.10.38, and you wanted to divide this network in such a way that each network should have 40 servers minimum. Again, you will write out the chart 4, 8, 16, 32, 64, 128. Again, write the double of that. 2, 4, 8, 16, 32, 64, 128, 256. Right now, you wanted to have minimum of 40 hosts. The 40 comes between somewhere between 32 and 64. And take the maximum of that, which is 64. That means how many bits you need to hijack from the subnet mask. Write down the subnet mask into binary version. 1, 2, 3, 4, 1, 2, 3, 8 ones, 8 ones, 8 ones and zeros. Now basically you need to leave 6 bits from the host as it is from right to left now. Right to left, take down the 6 bits and convert the remaining bits which are left over into ones. Let's say instead of 40 servers, let's say you want 30 servers. 30 is coming between 16 and 32. That means you need to convert, you need to leave first 5 bits from right to left, and convert the remaining bits into ones, which is 3 bits. Now, if you again convert this into binary 255, 255, 255, now 192 plus 32. If I place this and convert it to binary, it will be 192 plus 32, which is 224. This is your new subnet mask. And what is the increment? Increment is again the number of zeros. 5 zeros are there in the host, which is 2 for 5. 32 is the increment. Now write down the network. 192.168.10. Start with 0 and ends with 10 dot, not 32, 31, because we are including 0. And the second network starts with 32 and it basically ends at 63, 64 and ends at 95. Likewise, you can create n number of networks. You can divide the existing network into n number of networks based on the number of hosts that is required by you. So far, we have done a lot of calculations to create the subnets, basically divide the existing subnet into smaller parts. But while creating networks in Azure or AWS, do we need to perform all these calculations every time? The answer is no, because there are a lot of tools available online to make your life easy. Right? So I'm opening one tool where it's giving a good example. Right? So here for this IP address, having this subnet mask, if I have to convert this network into 4 different parts. Then how many subnet bits I need to hijack? 2. We already discussed in previous section. Then how many different subnet it's creating? 4 different subnets. Each subnet is having how many hosts? 60. Actually, it should be 64, but they are mentioning here as 62 because we already discussed one address will be used for network address and another network will be used for broadcast address. Right. So while you create any network, any subnet in AWS or Azure, you can use these kind of tools, but you need to understand the basics behind what is what. Otherwise, you'll be confused while troubleshooting the issues in your actual production environment. I hope this video helps you in creating your cloud and DevOps network environments. If you really like this video, please like and share the video to your friends. And if you want more such content in this channel, please subscribe to our channel. We are going to come up with new content on AWS plus Azure DevOps engineering. See you in the next video. Thank you very much for watching this video.